This is Chapter 5, Lesson 4, Polygons and Angles. A blank is a simple closed figure formed by 3 or more line segments. In that blank, you're going to write polygon. So a polygon is a simple closed figure formed by 3 or more line segments. The segments intersect only at their endpoints or vertices. You can use the sum of the angle measures of a triangle to find the sum of the interior measures of various polygons. A polygon that is equilateral, which means all sides are the same length, and blank, all angles have the same measure, is called a blank blank. In the first blank, you're going to write equiangular. Equiangular. And then the other 2 blanks, you're going to write regular polygon. Okay. So a polygon that is equilateral and equiangular have the same, is called a regular polygon. So they have to have those 2 things. So that all the sides have to be the same length and all the angles have to be the same measure to be considered a regular polygon. Okay. Regardless of the number of sides in a polygon, the sum of the exterior angle measures is equal to blank. In that blank, you're going to write 360 degrees. Okay. So, for interior angles, angles that are on the inside, you're going to use this formula. 180 times n minus 2. N is the number of sides that the polygon has. So for example, 1, 2, 3, 4, 5. Okay, this has 5 sides. It's a pentagon. I would take 5 minus 2 and multiply that times 180, which would give me the total interior, the sum of all the interior angles of the polygon. Notice for the exterior, they all add up to be 360. So they all go from this line here, and it's this angle that we're measuring. So this angle plus this angle plus this angle plus this angle plus this angle are what add up to be 360 degrees. All right, let's take a look at some examples. Example 1 says, find the sum of the measures of the interior angles of a decagon. Okay, a decagon has 10 sides. So I'm going to use the formula, S equals n minus 2 times 180. My n and the number of sides is 10, so I plug that in, I substitute it in. 10 minus 2 is 8, and I multiply that times 180, which gives me 1,440. So the sum of the measures of the interior angles of a decagon is 1,440 degrees. Example number 2 says each chamber of a bee honeycomb is a regular hexagon. Find the measure of an interior angle of a regular hexagon. So we're looking for one interior angle. In example 1, we were just looking for the sum of all the interior angles. This time we're looking for one specifically. So there's 2 steps. So the first step I do just like I did with example 1. Hexagon is 6-sided. So I find the sum of the measures of the angles, use the same formula, S equals n minus 2 times 180, n 6, because that's the number of sides. 6 minus 2 is 4. 4 times 180 is 720. So the sum of the measures of the interior angles is 720 degrees. Step 2, I divide 720 by 6 because 6 is a hexagon. That's how many angles are inside a hexagon. And we know it's a regular hexagon, which means that all the angles in the hexagon are the same. So the number of interior angles to find the measure of one interior angle. So the measure of one interior angle of a regular hexagon is 720 divided by 6, or 120 degrees. Example number 3 says find the measure of an exterior angle in a regular hexagon. So again, hexagon is 6-sided. So the formula that I'm going to use, let x represent the measure of each exterior angle. So 6x, because there's 6 of them, because it's a hexagon, and they all have to equal 360. So I divide 6 from both sides. So x equals 60. So each exterior angle of a regular hexagon measures 60 degrees. So here's some examples of interior angles in regular polygons. So if a shape is regular, all of its angles are the same size. So here we have an equilateral triangle. So we can see all the sides add up to 180, all the insides add up to 180. Okay. One angle is 180 divided by 3, which is 60. Remember, it's equilateral and equiangular because we're dealing with regular polygons. A square is 360 interior angles measures, and one angle equals 90 degrees. Here's for regular pentagon, regular hexagon, a heptagon, which is 7 sides, and an octagon, which is 8 sides. Okay. So if the polygon has n sides, the angle sum is n minus 2 times 180. Then I divide this answer by n to get the size of one angle. So this is how I get one angle. 180 times the quantity n minus 2 divided by n. And for exterior angles, the interior angle of the x and the exterior angle of a shape add up to 180, okay? Because they form this straight line here. So the interior plus the exterior equals 180. This is because angles on a straight line equal 180. So remember, they're supplementary, okay? So if I equals 60, because it's a triangle, it's an equilateral triangle, then E has to be 120. So 60 plus 120 gives me 180. The sum of the exterior angles of a shape is always 360, so always a full turn or a circle, okay? So if I added each one of these together, I would get a full circle. If the shape is regular, then each angle is the same size. So remember, regular polygon, equiangular, equidistant sides, okay? You can find the sides of one angle by dividing 360 by the number of sides n. So example, for a triangle, I can take 360, and there's 3 sides, and divide 360 divided by 3, which would give me 120. All right, so there are a couple of try it problems out on this page. I want you to go ahead, pause the video, try them out, and when you're done, we will go over the answers together. All right, now that you've had a chance to go over the try it problems, let's go over the answers together. So letter A, B, and C want you to find the sum of the interior angle measures of each polygon, okay? So my formula, hexagon, so my hexagon is a 6-sided, so my formula is n minus 2 times 180. So I'm going to do 6 minus 2 times 180. which is 4 times 180, which equals 720 degrees. Okay. Letter B is an octagon. Well, an octagon has 8 sides. So here's my formula. 8 minus 2 times 180, so 6 times 180 equals 1080 degrees. Remember, I'm just finding the sum. I'm not finding specific angles. Okay. Letter C is a 15-gon. So that's 15 sides. So 15 minus 2 gives me 13. And 13 times 180 is 2,340 degrees. Letters D, E, and F say find the measure of one interior angle in each regular polygon. Round to the nearest tenth if necessary. So first one I have is an octagon. An octagon has 8 sides. So my formula is 180 times n minus 2 divided by n. So I get 180, 8 minus 2. I'm going to divide that by 8. 8 minus 2 gives me 6. 6 times 180 is 1080 divided by 8, which gives me 135 degrees. Letter E is a heptagon. A heptagon has 7 sides. There's my formula. So this equals 180, 7 minus 2 divided by 7. So 180 times 5 divided by 7. 180 times 5 gives me 900 divided by 7 gives me 128.6 degrees because I'm rounding up to the nearest tenth. For letter F, I have a 20-gon. So that's 20 sides. So I fill that in with my formula. So 180 times 20 minus 2 over 20. So that's 180 times 18 divided by 20. 180 times 18 is 3,240. And then divided by 20 is 162 degrees. So one angle of a 20-gon measures 162 degrees. Letters G, H, and I want you to find the measure of an exterior angle of each regular polygon. So it's important to note that they're regular polygons, okay? So we'll start with triangle. A triangle has 3 sides. Remember, exterior angles add up to be 360. So I'm going to take 360 divided by n, and my n is 3, so it's 360 divided by 3. So each side, or each exterior angle, equals 120 degrees. Okay. Letter H is a quadrilateral. Quadrilateral has 4 sides, so 360 over n, which is 360 divided by 4, so that's 90 degrees. I, octagon. An octagon has 8 sides, so 360 divided by n, 360 divided by 8, so that gives me 45 degrees. And that is the end of lesson 4.